Okay. In the previous discussion, we come to the feasible region. 1, 2, 3, 4. You have 4 corner points. In order to fully determine the feasible region, you also need to find what? This corner point. Okay? So how are you going to find this corner point? Well, we need to solve what? The simultaneous linear equation. So in other words, 2x1 plus 3x2 equal to 6. And then 2x1 plus x2 equal to 4. If I call this is equation 1, I call this is equation 2. So what happens if equation 1 subtract by equation 2? Okay, so let's take a close look. Two x1 minus 2x1 is 0. 3x2 minus x2 is 2x. Equal to 6 minus 4 is what? Is 2. 2x2 is 2, so that means x1 is what? No, that means x2 is what? Is 1. Okay? If you plug in what? Plug in equation 2. So you have 2x1, but x2 is what? Is 1. This equal to 4. So that means 2x1 is equal to 4 minus 1 is 3. So x1 is what? 3 over 2, which is 1.5. So we can fully determine the feasible region now. Okay? We can fully determine the feasible region. This one we know is 0, 2. This is the origin 0, 0. This is what? 2, 0. And this corner point is 1.5 and what? And 1. Okay? Now, a very special feature by LP is what? Is the optimal solution, if it exists, it must what? You must can find 1 on what? The corner point. Okay? So this is important property of what? LP problem. If the LP problem has an optimal solution, then you can always find 1 on the corner point. Or I say more precisely, on the what? The feasible corner point. In our case, this is the feasible region. It has 4 corners. So this corner point is also called feasible what? Corner point. Okay? So let's repeat the property. Okay? If the LP problem has an optimal solution, okay, or you say if an LP problem has an optimal solution, then you can always find 1 located on what? On the corner point of the feasible region. Okay? So second step, we are ready to determine the optimal solution based on this property. Okay? So let's look at the table. I list all the corner points. And the value, the function value. Okay, let's begin with 0, 0. And the objective function is what? Is W equal to 3x1 plus 2x2. So when the corner point is 0, 0, you plug in 0, 0 here, the function value is 0. Now let's look at what? How about we plug in 0, 2, another corner point, okay? 0 times 3 is 0. 2 times 2 is 4. So the function value is 4 here, okay? And then 2, 0. You plug in 2 here is 6. And 0 plus here is what? 0. So the function value is 6. And how about look at the very last one, 1.5 and 1. 1.5 times 3 plus 1 times 2. So this is 4.5 plus 2. This gives what? 6.5. Okay? So the 6.5 here indeed is the largest one. Okay? This is max with W equal to what? 6.5. Okay? Now, let me draw a final conclusion. Graphical method is very intuitive and very easy to follow. However, the most important restriction on what? On the usage of the graphical method is the weakness of what? Graphical method. Is the application only work for decision variables. The number of decision variables. Huh? It's only work for the number of decision variables. Is what? Less or equal to 2. You cannot work when you have 3 decision variables. So if number of decision variable if the number of decision variable is greater or equal to 3, then we're going to use what? Simplex method. Or we're going to use Microsoft Excel. Or you say this is computer.